All right. Hey everyone, welcome to the session on Intro to Coding. I'm going to go ahead and start sharing my screen. All right, so first little announcement, there will be no summer skills social this Saturday. We will be having one the next Saturday though, and it'll be another industry one. So make sure to keep an eye on emails for that. Today is first time coding in Python. And on Thursday, it will be graphic design done by another student. So if you're interested in that, feel free to drop in. So my name's Katelyn. I'm a rising junior in computer science at Notre Dame, and I'm currently the interactive app lead for the STEP project. As a little intro, Tarik, do you want to introduce yourself?
Yeah, so my name is Tarik Brown. I'm a undergraduate at the University of Notre Dame, computer science major. I've been coding for a while, and I've been looking for opportunities to help improve my teaching skills. So I'm grateful for everyone here today and to give you guys some exposure into coding.
Awesome. Well, so we are going to be going over coding, and Tarik is going to give kind of a basic outline of information that you need. But before we get started, I wanted to give a little explanation of kind of how coding is valuable in themed entertainment. So actually, the reason we're doing Python today instead of like another language is that someone reached out to me asking me to do Python specifically because it's used very heavily in the industry by companies, Disney, Universal, and other contracted companies. So that's why we're starting with Python. In particular, kind of things you can do with coding. I am currently making an interactive app for the STEP project. And if you don't know what the STEP project is, we're basically designing a theoretical theme park. And I'm currently using JavaScript and XML, which are two other syntaxes, languages that basically I'm using it to read barcodes, to make it interactive, using location-based technology to make certain quests, like kind of like a quest system, pop up as they walk around the park, so you can interact with characters in your area and that kind of thing. It's also used, we had a session previously on PLC programming, which is specifically for ride controls. So that's another way coding is used. And it's just generally like good information to have. Even if you don't go into coding, it's useful in that you can like kind of talk to someone who's like a programmer. Someone asked me to mention kind of what it's nice to like have a programmer, to have like a creative understand for communicating. And one thing that came to mind is computers don't see things in a whole picture usually. It's very much, I don't know if you've heard like ones and zeros, right? So computers understand individual points of data and they can follow instructions really well. So they do what you tell them, but they can't understand big pictures unless they're trained to. So seeing things like visually, it's very hard for computers to interpret pictures. And if you tell them like we're going to be building a calculator later today, they don't understand what a calculator is, right? They're just following the individual instructions we're going to give them. So that's something helpful that I didn't know about coding when I started to keep in mind for computers. But if you guys have more questions on that or more specific, we can definitely go over that later. But yeah, so feel free to take it away, Tarik, if you want to start on the basics.
All right, let's get started. So just going to go over what we're going to be going over today. So first things first, I'm going to introduce you guys to Python, tell you guys what is Python and why are we learning the language in particular. Then we're going to go over very fundamental concept in programming, which is what is a variable and what are their data types. And we're also going to go over some basic programming logic, which I like to call control flow. And then at the end, Katelyn's going to walk you through putting those skills together and building a calculator. Just to set some expectations, this presentation is more meant to be a way to expose you to programming, especially if you haven't had any experience before. So my advice would be do your best to really soak in the information and don't worry too much about trying to write down every single thing, but more trying to understand the concepts that we're going over. It's really meant to give you the motivation to go in the future and really apply these basic concepts that you'll learn here into helping yourself learn programming in the future. So first thing first, what is Python? So Python is a interpreted, object-oriented, and high-level programming language. These are all big terms that seem scary at first, but once you really dive into the world of programming, it'll become second nature. You'll hear it thrown around a lot, and it's really just buzzwords. It's nothing to get intimidated by, and it's something that you'll come to learn in the future. The main reason that Python is a really popular language is because it's easily readable and it has structured code sort of built into how you write code in Python. It's a free and open source language and has a large community and many online resources, meaning it's not only valuable in the tool set that it provides you, but there's also a lot of resources already in place to help you learn more on your own. So who uses Python? So big companies like Walt Disney, Google, Pinterest, NASA, Microsoft, Wyatt Intern, all of these companies use Python. Python has become a very popular language, and it's very versatile. You can use it in a lot of different things, website development, handling tons of data, graphic design, and it's just a very useful thing to know. Even if you don't necessarily have a technical role, Python could be something that could expand your tool set. So the first thing we're going to dive into is, what is a variable? So the first thing to understand is that Python is an object-oriented language. Okay, what does that mean? Well, in Python, a variable is a type of object. How are we supposed to look at objects exactly? Well, the great thing about an object-oriented language is that a lot of the tools that you use are sort of packaged into these objects. And these objects have specific properties that you know beforehand. So imagine if you're going grocery shopping, right? And you wanted to buy some bread. You sort of already know where to buy the bread, what types of food you can use to make with the bread, what the bread's called. And, it's sort of the same thing when you have like a grocery list. Sort of all the items on your grocery list are going to have certain properties and certain names. And that's akin to how objects work in this case. You can look at a variable as an item on your shopping list. It's going to have a name, it's going to contain something, and you're going to know where to find it. So in this case, a variable has the properties of a name, an implicit type, and a value. All I mean by implicit is that you don't have to define the type that the variable takes on. Python does that for you, which is another reason why it's pretty popular. So if we take a look over at this code snippet here, we have two variables. We have variable x that takes on the value of 1, and the variable me, which takes on the value of my name. So x has the name x, and the value that we're storing in it is the number 1. And the type in Python would be an integer. And me has a name me, and the value we're storing in it is my name, and that value would be a string. So we just had a very brief look at what data types would look like stored into variables. So now we're going to sort of go over what are all the different data types that we would need to know to make a basic calculator. First things first is an integer. Variable x is storing number 1. Integers represent whole numbers. The next thing is a float. Variable y is storing a float, and floats represent decimal numbers. And an important thing to know is that these two types support all the arithmetic operations that you would know, all the basic arithmetic. And just to show you a little example, we're going to go over to an online coding here. And just to show you, we'll have two variables. Say variable x equals 2, and variable y equals 3. We can add these two variables. and have our program print the total. You see here we've had variable 2, 3, add them up together, and we get 5. Just a few things to note out here. This def main is just a good way to organize our code. So one way Python is naturally structured is that all of your code has to be indented whenever you're working inside something. So main in this case is the function, which we're not going to worry too much about for this presentation. And inside this function, we've defined variables, printed them, and we've called it again so that the function actually runs the code. So we're going to go back. Now we're going to take a look at the string and character data types. So a string you can treat as a series of characters, and a letter you can treat as a single character. Another very important concept is the concept of casting. So in Python and many other languages, you can actually change the type of a variable. In Python, this is done through casting. So what do I mean by that? So the first variable here, number, you've actually stored it, the number 5 as a string. And then we have another variable here where we actually convert that string into an integer. And this is something that you become more comfortable with as you apply it in different cases. Also, just note, if you guys have any questions or if anything, want to go back to anything, I'm definitely down to do that. Just
Can I have a quick question?
Yeah.
The previous slide.
Yep.
So with casting, you have number equals 5 and new numbers like the integer of number. So then
right.
If number is equal to, say that's like your string, like your name, and then you take integer of, if you still take integer of number, would that not work then? Or would it just count the number of characters in your name and give you that number?
That's a good question. Let's find out. So let's say instead of this being a 2, let's make this my name. And let's put in the variables here. I just realized I put 2 plus 3 last time instead of variables. So let's see what happens when I try to add 2 plus my name. Right, so I get unsupported operand. Basically, you can't add an integer in a string. And let's see if I try to take my name and cast it. We get an error. You can't convert a string into a base 10 integer. So basically, you would get an error.
But then it would work, instead of your name, it was 5, but 5 is a string.
Right, because what it's doing is, or actually, I'm looking at the.
I think new y should be in the addition problem.
Yeah. So yeah, it would still work because it's trying to convert the string into a number and then saying, is this a valid number? So when you take my name, you try to convert it into a number, then that throws an error.
Okay.
Yeah. I have a question. What is the casting code to convert a number into a string rather than vice versa?
Let's see, I'm pretty sure you would just put the type. So in the presentation, I've been putting the full names of the types, but in Python, they're actually abbreviated. So let's say we have X. We want to make X into a string, and let's confirm that X is a string by printing the type. So we run this, I am in the wrong one. So if we run this, we actually get the string type. So, right, if you saw before, I had just X, and that type was int. If we cast it and print Y, we get string. So does that make sense? How casting is a bit complicated, and there are some restrictions, but it's nothing to dive too far into. But as long as you get the basic idea there, if you have a string that doesn't have any numbers, that's not going to convert into an integer well. But if you have a string that contains numbers, then that's going to convert. And basically for any type, if you want to convert from a number to a string, you would just write its class and then wrap it around the variable. Does that make sense, or are there any other questions on casting? Awesome. Okay.
All good.
We're going to go back. All right, so the last important data type we have is the Boolean. So one of the most important things in computer programming is logic. So knowing whether statements are true or false and knowing whether certain conditions have been met is sort of like the cornerstone of programming. And these two variables here are conditions of logic. So in Python, a Boolean can be one of two things, right? True or false. Something can either be true, and something can either be false. And this type is often represented in logical operations and expressions. So what does this look like? So now we're going to dive more into control flow. And the first thing we look at is the Boolean expression. So a Boolean expression evaluates a truth value, essentially whether a statement is true or false. For the purposes of the presentation, all of the Boolean expressions are going to be wrapped in parentheses. So if you look here, we have the variable x and the variable y. X is 5, y is 6. And in this statement, we're comparing x to y. In Python, this statement would return true. And you'll get a better sense of what that means as we go through. And in Python specifically, there are a lot of different ways to compare values. You don't have to worry about memorizing most of these. You can always search them up for reference. But essentially, you can compare if two values are equal. You can compare if they're not equal. You can compare if they're greater than. You can compare if they're less than. You can also check if two values are true, if only one value is true, or if a value is not true. All right, so how do we actually check whether something is true? How do we tell Python to check if the statement is true or false? So we do that through using conditional statements. So conditional statements are used to check those Boolean expressions. And this is often seen in the form of if statements. So the general syntax here, general way we write it, is we say, if some condition is true, do something. So by default, an if statement is checking if something is true. And if that thing is true, then it carries out the code within the statement. So let's go over and sort of type this example we have here. So we have n is equal to 5, and we say if n is exactly equal to 5, we're going to print n is 5. Right, so you see we get all the way down to this statement because we've taken a variable and we're checking if it's 5, and if that's true, we print n is 5. And again, the Python syntax sort of forces you to put the contents of what you want to run sort of indented one level into the if statement. Right, so if we change n to 4, we wouldn't get anything, right? Because that if statement wouldn't be true, and it's not going to print this statement. So another concept is alternative execution, right? What do we do if the statement we have in the original if statement isn't true? So alternative execution is when there are two possibilities and the condition determines which statement is executed. And this is seen in the form of if else, right? So if a condition is true, do something, else, do something else. So what does that look like? We go back to this example and let's include an else statement, right? If the number isn't 5, what do we do? Let's print. Now when we run this again, not sure where this error is coming from. Well, let's just pretend that this ran. And essentially it would hop into this next case. I'm not sure why this isn't. I think this this online editor might have some issues. That's okay. Right, so sort of the next thing here is chain conditionals. So if we have more than just 2 things that we want to check, we can actually add on more statements. And we do this through using chain conditionals. So it's a little different than just having an if and an else, because there's one more statement that we check before we do our last sort of default. And in Python, this is denoted by elif. So each condition is checked in the order that they appear. If one is triggered, the rest are skipped. What does that mean? So if the first condition is true, then it's not going to check the other conditions, and it will just do what's in the first condition. If the first condition is false, it will go to the second condition. And if that's true, it's going to run the code in the second condition. And if neither of these are true, it'll do what's in the last else condition. And it doesn't have to check a statement for the else condition because the else runs regardless of any conditional statement. So the next thing is conditional statements can actually be nested or placed inside one another. So for example, we can sort of have 2 checks if we want. If we go back to our original example, we can check if the number is 5, and we can also check if the number is greater than 3. And this is useful where you might have cases where the first case is true, but it's also important for the second statement to be true. Right. And sort of the last bit of logic that we're going to look at here is the while loop. Now, loops are a big concept in programming, but we're only going to look at the while loop just for the purposes of building a calculator. So a while loop can repeatedly execute a series of tasks. What does that mean? So you can have a while loop run until a certain condition is met. So if you go back here, and let's say it is 2, while less than 6, and let's add 1 to it. Right, so you see in our while loop, we sort of had a condition here, and how it works is the while loop will repeatedly run code until the condition that's specified is met. So here we start out with n equals 2. Then we said, okay, while n is less than 6, we're going to print n, and we're going to keep adding 1 to it until it reaches 6. And this process of repetition is something that's very fundamental to programming. A lot of different coding processes implement this idea of repetition using loops. And the last tool we need to know is input and output. So Python has a handy function that allows the user to interact with the program and take in a user input. And this method is called input. So you don't need to know too much about what methods are or how they work, but just for the purposes of making this calculator, know that if we have a variable and we set it equal to input, and we do open close parentheses, we can actually ask for user input and then print whatever they give us. And you'll receive a demonstration shortly. So we're going to move on to the code along portion. So you have to Katelyn.
All right. I'm going to put, let's see. I'm going to put that same link in the chat for anyone who wants to code along with me, and then I will share my screen, and I'll give a little demo of that input and output, and then we'll start on the calculator. So I'll kind of give everyone a minute if they want to get on that program.
And does anyone have any questions? Does anyone want to go back to anything? Cool.
Good. Okay. All right, so here we have what Tarik had on the last slide. We're going to do the input and output, and I'll show you guys what happens. Also, if your eyes hurt from looking at this white screen, this Tarik had his set like this. It's a little easier to read. Dark mode versus light mode. Dark mode is a little easier on the eyes, so that might be a good idea. All right, we'll go ahead and run it. This is enter a number, so we'll put 5, and then it prints 5. So it took it in, and then it printed it out. Not too bad. All right, do you guys have any questions on that, or are we good to start on the calculator? Good, all right. Okay, so one thing, I didn't know any coding when I went into college, so I started on the basics, and one thing I learned that I thought was really important was not to code something all at once and then test it. It was to start out little by little and build it and test it as you go, so you don't get to the end and have a bajillion errors and not know where they came from. So starting with the calculator, if we start basics, if we say A equals 3, B equals 4, and our answer equals 3 plus 4. All right, so just to make sure this works, we're going to print the answer. Oh, and when you get on the website, also make sure that you're selected on Python 3, otherwise it'll try to run other coding languages, and that will not go well. All right, so run it, and just like we expect, we get 7. Okay, but of course, when you're making a calculator, you don't want your user to have to edit the code itself. You want to take it as an input. So like we learned in the last example, we're going to use the input method and say, please enter your first number. Usually it's helpful to include a little space here, because if not, when they input the number, it'll show up right next to the colon, which looks a little messy. And then we're going to change the answer to A plus B. My mistake on that last time. I'll give you guys just a second to get caught up. All right, I'm gonna make this a little bigger so it's easier to see. When we run it, it'll say, please enter your first number. You can do 4. Please enter your second number, say 12. Uh-oh, issue. It put the numbers next to each other. So this is something that you kind of just pick up as you go. The input method takes in values as strings or as characters, right? And this plus sign, when it gets a string or a character, it reads a string or a character, it just puts them next to each other. It doesn't actually add them because they're not numbers. So this is where we want to use the typecasting. And we want to change what the input saved as a string and change it into an integer. And then try it again. So now we have 4, 12. All right, it's working, we got our answer. All right. But of course, we don't want a calculator that just adds. That wouldn't be a very good calculator. So let's start out with creating a menu for our user, right? So that they know what their options are. So maybe we say addition, print, subtraction. Oop. Yep. Print multiplication, if I can spell right. And print division. Now, we also need a way for them to actually make their choice, right, of which function they want to use. So we're going to create another variable called choice and make another input statement. Now, for reasons I'll go to in a bit, we just want them to pick the first letter of whatever function they want. And I'll kind of explain why it has to do with the if statement we'll get into in a moment. So also another thing to keep in mind is when you're naming variables, it's really good that if you know their purpose when you're creating them, which hopefully you do, you give them some name that's meaningful, right? I was actually working with code recently that I didn't write, and the person who programmed it had made all the variables A, B, C, D, and it was so hard for me to like track back and figure out what all of these variables meant. And you can figure it out, it just takes a little longer. So that's why I named mine choice. You can name yours whatever you feel like is easiest for you. So please enter the first letter of your choice. And then we can say, we're going to start using our if statement. So depending on their choice, we want them to either do addition, subtraction, multiplication, or division, right? So let's say if their choice is A for addition, all right? We want it to do this function, right? And because tabs and indentation is important, we want to make sure that we scooch all of this over one so that Python understands that this is what we want it to execute. All right,
quick question, is there a difference in Python between single quotes versus double quotes?
Sometimes it depends on what you're using it. If you're asking in this case,
yeah.
I believe, and Tarik, you can correct me if I'm wrong, I believe single quotes indicates that it's a character. Is rather than a string, but I think either should work. We can try it.
Okay.
We want to test it out. So let's see if we run it. I'm going to put A, 3, 4, and it works. So in this case, there was no difference. One example of a difference is that if I put a single quote in here, it works just fine. But if I were to make this a double quote for some reason, it would end the string.
Right.
And so this would cause an error.
Mm-hmm.
But in that case, it does not matter.
And I think the convention is that single quotes are for characters and double quotes are for strings, but it doesn't really matter.
Awesome. All right. Also, if this double equal sign is kind of weirding you out, another way you can do it in Python is just write is. So if your choice is A, then it'll execute all of this. Next, we want to do subtraction. So else if is what that stands for, by the way. Else if the choice is S, then we want to have it do all of this, but with subtraction. So really easily, we can just copy and paste this. And then change this to subtraction. And do the same thing for multiplication and division. So else if choice is M, multiply, and else if choice is D, then we divide. Now, technically this is enough. This will do a 4-function calculator just fine. But if someone makes an error, a user might not know where it comes from and not understand why they're getting it. So it's usually helpful to put an else statement and say print whatever the problem is. So your choice was invalid. Please try again. All right, so I'm gonna wait just a couple minutes and make sure everyone's caught up. If anyone has any questions while we're waiting, feel free to go ahead and ask them.
Will, say like you reach the last conditional statement, we would also need something that allows another input afterwards, correct? To be able to go back to the top of the if statement?
Yes, exactly. We will get to that in a moment.
Okay.
All right, so let's give this a shot. So addition, subtraction, multiplication, division. Let's go with subtraction. We haven't done that yet. Let's do 8, and let's see if it can handle negatives. -4. All right, we're looking good. All right, to give you guys an example of the else statement, I'm gonna put in a random letter. Your choice is invalid, please try again. All right, so that's what'll happen, and then it'll end. Now, here's something interesting to keep in mind. If I say capital A for addition, the choice was invalid. Programming languages or Python recognizes lowercase and uppercase as different things. So that's something to keep in mind. So maybe it would be better to say the first letter of your choice in lowercase. And then that way the user would always know what they wanted. All right. Now, the next factor is exactly what you guys are talking about, that you don't only want to use a calculator once, right? You want to be able to use it as many times as you want. So here's where the while statement comes in. So let's say we want to use we want this calculator to run forever. Okay, so we're going to put while 1. 1 also means true, and this means that this while loop will never end. So we want to put this, and we want to put all of this and tab it over so that our indentation is correct. All right, and then let's try running this to see how it goes. All right, so it gives us our menu. Please enter the first letter. I'm gonna say addition. 19 and 7. All right, it gave us our number. Oh, did it not work? Oh no, there it goes. All right, please enter your first number. Wait a minute, I don't want to do addition forever. Yeah, this is a problem. Does anyone have a guess of why it's stuck on addition? If not, I can just go over it, but I'm curious.
I mean, you're still within the, if choice is A, you're still within that if statement. Actually, shouldn't it exit the if statement once it's completed?
It does, so it does exit the if statement.
Oh, but then it goes back to while, and then choice is still equal to A.
Exactly, so within the while loop, you're never getting a chance to change what choice is, right? It's so I put it in as A, and it says, okay, choice is A, I do this, I go out, while again, oh, the choice is still A, and it just keeps going. So we want to copy and paste this also inside of the while loop. So once it exits the if statement, uh-oh, that's right, I gotta stop it. So once it exits the if statement, I want to make sure to go back to the same indentation level as the if statement, so that way it doesn't register it as being under else, and then print all of this. Also making, whoa. Also making sure that this choice variable is the same as the one up here, so that, well, for reasons I'll explain later, but to make sure that it's replacing the same variable.
One question here, could we just, rather than like having it appear twice, could we just put it once at the top of the while loop?
Yes, so yes, we could right now, but I will get to why in a moment. We won't be able to do that for this next iteration that I'm going to do.
Okay, cool.
Yep. All right, so we have this, make sure it works. All right, we're looking good. It's letting us change our answer now. Sorry, I can't see the very bottom of the screen. 32, perfect. But now how does the user get out of this? We have a stop button, or you can also use Control-C, that command will get you out, but a user doesn't know this. So we want to add something that lets them escape this while loop. So on our menu, we're going to add an option, print exit, okay? And we're going, and we do that down here too, for consistency. And we want to change this while loop to say if the choice is not E. Okay, so if a user ever puts their choice as E, the while loop will exit and the code will end because there's nothing else down here after the while loop. Great, so I'm gonna run that and show that working. So we have addition 3 and 9, 12, great. I hit E and it exits the program. So Jake, to answer your question, the reason why we can't put this inside the beginning of the while loop is that if we do this, make it like this, the choice variable does not exist yet, right? And so it has no value. And so when the while loop checks while choice is not E, it'll do something completely weird. Sometimes it'll give an error. We can check and see what Python does. I'm not sure specifically, but sometimes it'll give an error. Sometimes it'll just take whatever value the computer has saved in a random location and say, oh, this is probably what they're talking about, and like run that. But here we can see what it does. Yep, so it says choice is not defined. So that's why you have to do the kind of strange thing of putting it outside the while loop and then putting it again at the bottom. Oh, I see something.
Follow-up question on that. Would there be a command? So say we still had it at while 1. Is there a command that could like force break us out of it? Like you said, if choice is E, like break out of the while loop?
So,
does that exist?
if you're stuck at while 1, like this, and you run it, and you're asking like, how would a user break out of this without the stop button?
Well, I'm saying in the code itself. Like, is there a command that says like exit while loop or something? Like,
Yeah,
so then you could say else if choice is E, like end the program or like leave the while loop.
Yeah, so then, yeah, definitely. There's something called break statements. And so breaks will break you out of whatever loop you're in currently. So you're definitely right. So we could put elif choice is E, and then we could say break. I believe break works in Python. I learned in C++, so that's where a lot of my stuff is. All right, and then you're thinking bring this back up here?
Yeah. I'm just kind of trying to imagine it.
And then I think also maybe if you predefine choice before, oh, actually, no, never mind, because we have while is equal to 1. Never mind.
So let's give this a shot. So now if we put E, and it exits, so that definitely works.
Okay.
Break statements are pretty handy. There's something in C called a switch statement that would actually be really useful for this, and in it you'd use break statements, but Python doesn't have those.
Also, sorry, can you scroll to the bottom? So we have E is equal to just the text exit. Is that correct?
Sorry, what's that?
Oh, because break gets you out of the while loop, but that doesn't quit the program from running,
right.
Or does it?
It doesn't. So it breaks you out of this while loop, and because there's nothing after the while loop.
Oh, then it just ends.
It ends. Yeah.
Okay.
So if I were to go over here and I would indent back to the same level as the while loop, right? And I print program ending, and I run this, and I say E, it'll say program ending.
Okay, and then it just ends because.
Right. Or I can put, if it makes it clearer, let's see. This is the last thing in the program. Yeah, that might be a better way to phrase it. All right, good questions. Do you guys have any other questions or anything you'd like to test?
Oh, I'm being a nerd, and I'm, instead of repeating inside if basically the same thing, I remember what Tarik showed with having the def main. So I'm just making a function. I think that's what it was, right? Like def main, and main was a function. So then like A is like, or like if choice is equal, or if choice is A, then addition, and then defining what addition is beforehand.
Yeah, absolutely. So okay, so I'm gonna do one function and then I'm gonna change it so that we'll do exactly what you said. But so like you said, it repeats a lot, like that input. Now with this layout, we could also just move this A and B up here, but that wouldn't quite work with the previous setup. This made it look a little cleaner, but we could also say like get inputs, right? And well, we'd have to pass variables, which would make it a little trickier. So yeah, let's just do what you were saying. Get addition and do this. And then we also want to print from within. Right. And then right here, we can call and give that a shot. All right, and now it asks us for our first number, so that's good. 18, 2, we got 20, and it keeps going. I kind of like to think of functions as like boxes that like the program knows what's in the box, but unless you call it down here, it won't open the box. That's kind of what I think. So we can definitely do this to make it look cleaner. I keep forgetting about that. Define get subtraction, and then do that for all 4 of them. But I won't do it for all of them. I'll just do this one. Sorry, we keep going. All right, I see there's a chat. Let me check on that real quick. All right. Okay, so Jessica asked, could the while loop be replaced with a for loop? You could replace it with a for loop, but that would limit the amount of times that it goes around. So a for loop is for a certain number of rounds, it'll loop, if that makes sense. So I could say, you could say theoretically like, here, I think I can do. Have we done for loops in Python? Let's give it a shot.
For loops are a bit different because you have to like define a range. So you have to like, you have to be like for I in range.
Right, so for I in, not range 100. And then here, I'm gonna, I don't wanna, are you guys okay if I erase this or you still want it? We doing okay? All right. All right, I'll erase it. I'll bring it back if you guys want it. I have it written up also elsewhere. So for I in range 10, print I. So if we run this, it's going to print 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And so something interesting is that range, this method, starts with 0. So it has 10 digits in it, but it does not print the value 10 because it counts 0 as a digit. So those are kind of how for loops work. You can also get a for loop to iterate like over a list of values, kind of, if you make a list. Python is actually really nice with for loops because it like figures a lot out for you, but yeah, so that's how a for loop would work. And let's see, is there another chat question? Does anyone else have any other general coding questions or questions about this system?
Can you talk a little bit more about how this is object oriented? Because I
Yeah,
think,
do
I
you
believe,
wanna-
because I've coded in C++ before, and that's not object-oriented, right? So I'm just wondering, like, what the difference is
I can-
besides the how it looks right now.
If I can share screens real quick.
Yeah, for sure.
Let's see. Right. So one of the things that I realized, like, why Python was very powerful, is because, like, if you take something like n equals my name, something like that, right? You can actually, like, if you type S, right? So the editor is going to suggest a bunch of things that this can do. So why is it like this? It's because n is an object, and in Python, the string object has all of these methods attached to it. So in other more strongly typed languages like C++, some of these functions exist, but if you like dive into it more, you'll see that, like, Python has a ton, like, everything you type in Python is an object. Like, any variable has these like methods that are attached to it, and functions also have these. And it's not just what you have to explicitly define. Python is just sort of like a set of these objects, if that makes sense. Like, you can, it's a very versatile.
Can you give an example? Like, just, I don't know, clicking one of those ones in that list?
Yeah, so if I remember, I can't remember what slice, I think it's like you can slice like the first 3 characters, right? So this is just something that's inherent.
It accidentally deleted the.
Oh, what? Yeah, I'm also not sure. I'm not sure this is going to do. Let's see.
It tricked us.
Maybe this is for an array. What's a good? Let's see. Split a string. This is also something that a lot of programmers do, which is search up stuff.
Google.
So there's the split method. So I can actually take a string and split it. And so I can actually take this string and I can split it into, like, a series of strings. And in C, like, this is an inherent function. I don't believe there's a dot split in C++. I could be wrong.
Not that I'm aware of.
Yeah.
Yeah, I think you have to
like,
do something complicated.
Yeah. You have to make a function that's going to do it for you. But, like, in Python, it's literally built for you. That's one of the reasons I really like it, because if there's something you want to do, you usually just have to press dot and then, like, see what the editor suggests to you, and you can do it. And that's one of the good things about having an object-oriented. Now, again, a language doesn't have to be object-oriented for you to have an object-oriented style of programming. So, like, even if you had C++, you could still have a lot of functions that do these things for you, and you can make it more object-oriented. But Python is, like, an inherently very object-oriented language. So that's what I mean by, that's why it's very useful and powerful in that aspect.
But yeah, Python's interesting. I started on C++ and, like, Python figures things out for you. And when I started using Python, I was like, oh my gosh, it just knows.
Yeah, I remember somebody was trying to teach me, like, just really simple stuff, because I had to code on a Raspberry Pi, and that's in Python. And he was like, oh yeah, there's just a library, just look it up. And I'm like,
yeah,
what? There's a library? How do I even go through this?
Yeah.
Usually if you want to do something, Python has an easy solution most of the time.
And one thing that's good about coding is like once you have these basics down and you like understand how to use them, then learning other languages is frequently like just at least at this level, just learning new syntax, right? All of the like core concepts and like the way you program stays the same. It's just understanding how to use the different syntaxes. So it's pretty good. And how to like, I personally think like it's easier to go from C++ to Python because you understand how to do all the hard stuff. And so then you like get to do the easy stuff. Whereas like going from Python to C++, you have to learn like how to define, you know, or how to oh goodness, what's it? Like define variables by their type. Because in C++ you have to say like int A, right? And int B, and not like, oh, it'll just figure out that like, I want it to be an integer. So anyway, does anyone else have any more questions or anything they just want to talk about coding related that we might be able to answer?
Can you add functions onto functions, or you said methods? Like if you do n dot split dot something else.
Yeah.
It's hard to find, but there might be an example of that. Like there are some like methods you can just keep doing dots. It's totally possible.
And it's so funny. I know we definitely did that in our systems programming class this last semester, because like, so you saw how it took the string and it made it into a list of smaller strings. So if you're parsing data, so like let's say you have a whole website full of like HTML that you want to parse through, right? Maybe you'll like split it by a line and then use another method on each of those pieces to like search for a word or something. And so you want to do like dot split dot search, which is not a real method, but it gets the idea across. And so that's kind of when you'd do dot dot. Alrighty. Last call for anything else?
I got a question. So like, is there a way? So my experience has been with Java, and that was in high school when I took AP Computer Science before they changed everything. So like, is there a way to write functions as public or private in Python?
I'm trying to think. I don't think I've done much classes, but I can do a quick Google search.
Yeah, in C++ there definitely is. You can have public and private variables and functions, and methods. I believe in C++ they're methods.
So it looks like you definitely can. Yeah, you definitely can have public and private methods.
Yeah, for anyone who doesn't know methods, so you can create, you can kind of create your own object where you like define different characteristics that it has. And you can also make methods for your object. Technically not an object, but we'll go with that. And these methods, you can either make them private or public. Public means that the user kind of can access them, or like people other than you can access them. And private means that only the programmer, only the one creating the file can access them.
So I guess what would be the benefits of using public versus private? Is that when you're actually publishing the code? And for instance, like with the calculator, right? Like the public ones would be the pieces of code in which we're saying, hey, user, give us a number or a character, versus private would be all the actual operations.
So I feel like it's a little more nuanced. Like for example, in my internship, I worked with like a huge code base, and what public and private methods help do, they help with organization, and they also help limit the scope of where things are used, right? So if you're only supposed to edit a variable in a certain place, I'm trying not to get like mention too many weird words. Like if you want a variable only to be edited when you add something, right? You want to make that private. Now you can keep it public, but there is a risk that maybe someone else that you're working with uses that variable. or it changes due to unexpected behavior. So it's really a coding practice. Like you can never make, you can like go through your entire life never making private variables, if that makes sense. But it's something that you want to help have better code.
Cool.
It helps to prevent accidents, people accidentally changing stuff it's not supposed to be changed.
Better hide that source code. Not like the leaks that happened with Nintendo and what was the other company a while ago? Oh yeah, Valve went with with games like Team Fortress 2. Yeah, that was bad.
Yeah, and again, I would also encourage you to like just search up stuff, because usually people have written like entire articles or books about just one topic, so it's all out there.
Yeah. Stack Overflow. Our teachers say not to use it, but it's definitely helpful. One nice thing about coding is like the coding itself, it's all out there online. What's really the benefit of getting taught it is learning like coding practices, like what I said, which is why I mentioned it, because that was kind of the important part was don't code all at once, do it in steps so you check yourself as you go. But the actual syntax and everything, all of it's online. And so it's very conducive to self-teaching if you're interested. Or if you ever want to reach out to me or one of us, feel free.
Do you have any resources on where we can go to like self-teach if we wanted to?
Yes. Google.com. No, I'm just kidding. Stackoverflow.com is one. I'll put it. That's like a good question and answer help.
I mean, it really, when I, like, they're definitely, like, YouTube is a great resource. But it's hard to give a specific, you should go to this website and use, like, these resources. I think the better thing is to just let your motivation guide you. So, like, if you want to make, like, if you want to do something specific, you can find out how to do that in Python, and you can search, and that will lead you to maybe a series of videos or an article or tutorial. But it's hard to pin down specific resources. I'd say, honestly, our computer science professor, Peter Bowie, he has his entire curriculum online, and I think it's great. He has like I'll link it. He has like an intro to computing like course, and you could go through the slides and you'll basically learn like a first year programming all in one course. So I just linked it. I think that's a great resource.
Bowie is fantastic. Great teacher. I'm taking him again this semester because he was good. But
His name is Bowie.
Peter Bowie, yeah. B-U-I.
Like if you're looking
face.
If you're looking for something rigid that will give you assignments, that will take you step by step, I would just go through his website and literally go through every slide and every piece of reading and everything that's on there.
What languages does he usually teach?
I think this course is the one I linked is Python, but he also has a course in C. He also switches between languages, so I think he mostly switches between C and Python. But the one I linked will be a mix of C. I think that he also does like some web stuff with HTML and CSS.
I also do want to say that like having a project to motivate you and like kind of drive what you're searching for is really great. It's sometimes tricky to find a project, but I know that I wanted to learn JavaScript as something this summer. And so doing the app for STEP has been great for that because it's had like, I have specific goals for the app that I want to make. And so it gives me a direct place that I could search like, how do you do this on JavaScript? And then through that, I've learned about like different statements you can do and like how variables work kind of between JavaScript and XML files. And XML is kind of like another version of HTML. You can kind of think of it like that, which is used for websites. So that's definitely a good place to start. And it can be anything as simple as, you know, creating a calculator to building a whole app, which is interesting. All right. Any other questions?
So, what are your thoughts on C++? I'm thinking about learning C++ because of heard that it's like it covers like a broad range of industries, especially like robotics and what I plan on doing.
Yeah, I don't know, Katelyn, do you want to go?
No, you go, you're good.
I know, because I actually did robotics in high school, and like we mostly use like Java and C++, and even working at big companies, they like to use languages like C++ and Java because it's very structured. So it's very easy to have like 100 people work on the same code and not have people like ruin each other's code, or you can have someone pick up where someone left off 5 years ago because all the data types are defined. Everything is, you know, strongly defined. So I definitely think it's very valuable if you're looking to get like a job or like a career in a certain field like robotics. But if it's just for personal interest, if it's just like you're trying to pick up some skills that you've never done coding before, then learning a language like Python would be better.
Yeah,
Unless-
I learned the hard way with Java. So
There's also like if you want to code with Arduinos, like Arduinos use a language called process, or it's like Arduino processing. It's basically C++. So that's also a good thing if you want to like program in Arduinos and be able to tinker around with that, and then also those like lend itself to robotics as well. Then learning like at least a little bit of C++ is always helpful. But again, like Katelyn and Tarik basically showed you the basics of what you need to know. Like if you want to blink a light, it's just like you just define your variables, except they just look a little bit different.
yeah, I've done those projects in my college. So.
Yeah. Okay, I gotta go, but thank you so much.
Absolutely, thanks for coming.
No problem.
Bye.
All right. Yeah, C++ is probably my favorite, but I'm a little biased because that's my first one. All right. In that case, I'm going to go ahead and stop the recording.
Bye.